Good morning, senior high school students of Valenzuela City. Welcome to Valenzuela Live Facebook live streaming in General Mathematics. Come and join me as we venture in our first learning experience. Are you ready? Let's start. We are now on week 1 of the first quarter, which is about key concepts of functions. At the end of this session, you are expected to meet the following most essential learning competencies. First, represent real-life situations using functions, including piecewise functions. Second, evaluate a function. Third, perform addition, subtraction, multiplication, division, and composition of functions. And fourth, solve problems involving functions. Let us first have a recall about function, which you learned in your previous grade levels. Do you still remember its definition? By definition, a function is a relation defined as a set of ordered pairs x, y, where no two or more distinct ordered pairs have the same first element x. That is, every value of x corresponds to a unique value of y. Let's have a quick check of how well you remembered function on our first activity entitled React on Me. I'll be flashing different examples of relation, and you need to determine whether the given relation is a function by hitting the heart reaction button, or not function by hitting the sad reaction button. You will be given 5 seconds in this. Are you ready? Okay, let us begin. First, the set of ordered pairs 0, 1, 1, 2, 2, 3, 3, 4. Function or not function? Time's up. If your answer is function, you are correct. Since every element in X appears only once, those are 0, 1, 2, and 3. The table of values with X as 7 and Y as 1, 2, 3, and 4. Function or not function? Time's up. If your answer is not function, you are correct, since the element 7 in X appears more than once. What about this mapping diagram? Function or not function? Time's up. If your answer is function, you are correct, since the elements which are the letters A, B, C, and D in X are paired once. How about this graph? Function or not function? Time's up. If your answer is not function, you are correct, since if a vertical line is drawn in any part of our graph, it crosses our graph in more than one point. And what do we call to this kind of test? Very good. It is called the vertical line test. What about this one? That this equation represent a function? Time's up. If your answer is a function, you are correct. This is a function. And in fact, you may recall that this is an example of a quadratic function. What is your score? Very good, grade 11. It seems that you remembered well the previous lessons. I guess you are now ready for our lesson. Let us start today's lesson with a problem that goes like this. You wish to buy a box of vitamin C that costs 700 pesos per box. How much will you pay for buying 3 boxes of vitamin C? 5 boxes. I'll give you 20 seconds to key in your answer on the comment box. Time's up. If you answered 2,100 for 3 boxes and 3,500 for 5 boxes of vitamin C, then you are correct. Functions, just like other math concepts, has its application in our day-to-day living. They may be used to model situations or phenomena in different fields like business, agriculture, engineering, health, and many more. The problem earlier represents functions in real life. In that problem, suppose that C is a function that relates the total costs of purchasing X boxes of vitamin C at 700 pesos each. Then, the scenario earlier represents C of X is equal to 700X. Let us have another example. A breakfast cereal company manufactures boxes to package their product. For aesthetic reasons, the box must have the following proportions. Its width is 3 times its depth, and its height is 5 times its depth. A. Find a function that models the volume of the box in terms of its depth. B. Find the volume of the box if the depth is 2 inches. To find a function that models the volume of the box in terms of its depth, we have volume is equal to depth times width times height, where x represents the depth of the box. Thus, we have v of x is equal to x times 3x times 5x. Getting its product, we have v of x is equal to 15x raised to 3. And this is the function that models the volume of the box in terms of its depth. For letter B, to find the volume of the box if the depth is 2 inches, we use the function v of x is equal to 15x raised to 3. Next, we simply substitute 2 in the variable x, then perform the operation. That is, v of 2 is equal to 15 times 2 raised to 3. 2 raised to 3 is 8. Multiplied by 15 is 120. So, v of 2 is equal to 120. The volume of the box is 120 cubic inches when the depth is 2 inches. Moving on, let's have this next example. Suppose your mobile plan charges you 300 pesos monthly. The plan includes 100 free text messages. However, in excess of 100 text messages, you will be charged 1 peso for every text message sent. How much will you pay for sending A, 50 text messages, and B, 170 text messages? I'll give you 20 seconds to key in your answer on the comment box. Time's up. What is your answer? How did you get your answer? The table shows the number of text messages sent and its corresponding cost. It is stated in the problem that the plan includes 100 free text messages for 300 pesos. So, for sending at most 100 text messages, the cost is fixed at 300 pesos. However, in excess of 100 text messages, you will be charged 1 peso for every message sent. So, for sending 101 text messages, you will be charged 301 pesos. For sending 102 text messages, you will be charged 302 pesos, and so on. Observe that the number of exceeding messages is computed by subtracting 100 from the total number of text messages sent. Hence, if there are X messages sent, there are X minus 100 exceeding text messages. Thus, the cost for this will be 300 plus the quantity X minus 100. Since the cost varies based on the two conditions in the problem, the function involved in relating the number of text messages sent and its cost can be expressed as a piecewise function. A piecewise function is a function defined by different formulas for the different parts of its domain. From the problem, we may represent the number of text messages sent as X. Since the plan includes 100 text messages for a fixed price of 300 pesos, then if X is greater than 0 but less than or equal to 100, the cost to be paid is 300. However, the excess from 100 text messages will be charged 1 peso per text message. So, the number of exceeding text messages may be expressed as X minus 100. Therefore, if there are more than 100 text messages sent, the cost to be paid is 300 plus X minus 100. These situations can be modeled by a single piecewise function, which is f of x is equal to 300 if x is greater than 0 but less than or equal to 100. And 300 plus the quantity x minus 100 if x is greater than 100. For letter A, the value of x is 50 and is found in the interval x is greater than 0 but less than or equal to 100. So, you will pay 300 pesos. For letter B, the value of x is 170 and is found in x is greater than 100. Computing for the amount to be paid, we have f of x is equal to 300 plus the quantity x minus 100. Substituting 170 to x, we get f of 170 is equal to 300 plus the quantity 170 minus 100. 170 minus 100 is 70. So we have 300 plus 70, which gives a sum of 370. So you will pay 370 pesos. Did you get the same answers? Good job! Now, I want you to think of this question. Is it possible to obtain a new function from the original functions? How? That is through performing the operations addition, subtraction, multiplication, division, and composition of function. When we obtain a new function by adding, subtracting, multiplying, dividing, and composition of functions, these new functions are called the sum, difference, product, quotient, and composite of the original functions. Let us have the following definitions. Given two functions f and g, their sum, denoted by f plus g, is the function defined by f plus g of x is equal to f of x plus g of x. Their difference, denoted by f minus g, is the function defined by f minus g of x is equal to f of x minus g of x. Their product, denoted by f times g, is the function defined by f times g of x is equal to f of x times g of x. Their quotient, denoted by f over g, is the function defined by f over g of x is equal to f of x over g of x, where g of x is not equal to 0. Let us have the following examples. Given that f of x is equal to 2x plus 6 and g of x is equal to x plus 3, find the number 1 sum, number 2 difference, number 3 product, and number 4 quotient of the given functions. Given that f of x is equal to 2x plus 6 and g of x is equal to x plus 3, the solution for number 1 is as follows. The sum of two functions is written as f plus g of x, which is same as f of x plus g of x. Substitute the given functions we have. Quantity 2x plus 6 plus the quantity x plus 3, which is similar to 2x plus 6 plus x plus 3. Combining similar terms, we have 2x and x as 3x, 6 and 3 as 9. So, f plus g of x is equal to 3x plus 9. For number 2, given the same functions, let us find the difference. That is f minus g of x, which is similar to f of x minus g of x. Let us now substitute the given functions. We have quantity 2x plus 6 minus quantity x plus 3, which is similar to 2x plus 6 minus x minus 3. Combining similar terms, we have 2x and negative x as x, 6 and negative 3 as 3. So, f minus g of x is equal to x plus 3. For number 3, given the same functions, let us find the product. That is f times g of x, which is similar to f of x times g of x. Let us substitute the given functions. We have quantity 2x plus 6 times the quantity x plus 3. Applying distributive property, we have 2x times x is 2x raised to 2. 2x times 3 is 6x. 6 times x is 6x. 6 times 3 is 18. Then we have 2x raised to 2 plus 6x plus 6x plus 18. Combine similar terms. That is 6x and 6x as 12x. 2x raised to 2 plus 12x plus 18 is the product of the two functions. Lastly, let us find the quotient of the two functions, which is f over g of x. And that is similar to f of x over g of x, where g of x is not equal to 0. Substitute the given function, we have 2x plus 6 over x plus 3. Observe the expression. Is the expression 2x plus 6 factorable? Yes, it is factorable, and its factors are 2 and quantity x plus 3. So this can also be written as 2 times quantity x plus 3 over x plus 3. X plus 3 in numerator and x plus 3 in denominator are equal to 1. So, the final answer is f over g of x is equal to 2. We've done the first way to obtain new functions from the original functions. That is through addition, through getting the sum, difference, product, and quotient of the given function. Can you follow with our discussion? Great. Now, let us have the other way of obtaining a new function, which we will call as composite function. Given two functions f and g, the composite function, denoted by the symbol, which is read as f composed with g, is defined by f composed with g of x is equal to f of g of x. Remember that in computing f composed with g of x, apply first the function g to x and then function f to g of x. The given illustration demonstrates how composition of function is performed. We take the values of x in g. Then, the resulting values are substituted to f. Further, we can imagine composition of functions as real-life situations. For instance, f of x is our pizza and g of x is our pineapple. F of g of x is illustrated by pizza topped with pineapples, while g of f of x is illustrated by pineapples topped with pizza slices. Another illustration can be seen in the picture where f of x represents cookies and g of x represents ice cream. The composition of f with g is shown as a cookie filled with ice cream, while the composition of g with f is shown as an ice cream with some cookies on it. Let us now have some examples about composition of functions. Given that f of x is equal to x raised to 2 minus 3 and g of x is equal to 2x minus 5, find number 1, f composed with g of 4, and number 2, g composed with f of 4. From the given function, f of x is equal to x raised to 2 minus 3 and g of x is equal to 2x minus 5. Let us compute for f composed with g of 4. To start, we write f composed with g of x as f of g of x. We evaluate first the g of 4. That is, replacing x by 4 in the expression 2x minus 5. Then, performing its operation. Doing so, we have 2 times 4 minus 5. 2 times 4 is 8. Minus 5 is 3. So we have f of 3. Next to this is to evaluate f of 3. That is, we substitute 3 in place of x in f of x. This gives us 3 raised to 2 minus 3. 3 raised to 2 is 9. Minus 3 is 6. So, f composed with g of 4 is 6. From the given functions, f of x is equal to x raised to 2 minus 3 and g of x is equal to 2x minus 5. Let us compute for g composed with f of 4. First, we write g of f of x as g of f of x. We evaluate first the f of 4. That is, replacing x by 4 in the expression x raised to 2 minus 3. Then, performing its operation. Doing so, we have 4 raised to 2 minus 3. 4 raised to 2 is 16. Minus 3 is 13. So we have g of 13. Next to this is to evaluate g of 13. That is, we substitute 13 in place of x in g of x. This gives us 2 times 13 minus 5. 2 times 13 is 26. Minus 5 is 21. So, g composed with f of 4 is 21. Can you still follow with our discussion? Great. Our last example shows how functions are seen in problem solving. Let's take a look at this example. A milk tea store can produce a milk tea at 70 pesos. It is estimated that if the selling price of the milk tea is X pesos, then the number of milk tea sold each day is 220 minus X. A. Express the daily profit of the store as a function of X. B. Use the result in A to determine the daily profit given that the selling price is 120 pesos. The profit, P of X, can be obtained by subtracting the total cost, C of X, from the total revenue, R of X. The total revenue is the product of the selling price and the number of the milk tea sold in a day. So, R of X is equal to X times the quantity 220 minus X. On the other hand, the total cost is the product of the cost per milk tea and the number of milk tea sold in a day. That is 70 times the quantity 220 minus X. Factor the expression, wherein 220 minus X is the common binomial factor and X minus 70 as the other factor. Therefore, we have P of X is equal to the quantity 220 minus X times the quantity X minus 70 as the profit of the store. Using our answer A, P of X is equal to the quantity 220 minus X times the quantity X minus 70. Substitute 120. P of 120 is equal to the quantity 220 minus 120 times the quantity 120 minus 70. Perform the operation. That is 220 minus 120 is 100 and 120 minus 70 is 50. Multiply 100 by 50. So, P of 120 is 5,000. Hence, the daily profit is 5,000 pesos. That's it, grade 11. I am glad you made it to our last example. Now, let us check how well you understand our lesson for this day. Let us have our second and last activity entitled, Your Turn. I will be flashing questions. Answer them using the concept you have learned earlier. Be ready with your pen and paper that you will be needing in answering. 1 minute will be given for this activity. Is that clear? All right. So here is the first one. For your upcoming birthday party, you are planning to hire a catering service, assuming that holding a party is allowed that time. The caterer charges 200 pesos per head for 20 persons or less. 180 pesos per head for 21 to 50 persons. And 160 pesos and 160 pesos per head for 51 to 100 persons. A. Create the piecewise defined function for this situation. B. How much will you pay the caterer if 35 persons will attend your party? It's your turn, grade 11. 1 minute starts now. Time's up. Let us check your answer. For letter A, let X be the number of persons, and this should be the piecewise function. F of X is equal to 200X if X is greater than 0 but less than or equal to 20. 180x if x is greater than or equal to 21 but less than or equal to 50. And 160x if x is greater than or equal to 51 but less than or equal to 100. Did you get the same answer? I hope so. What about the letter B? X is equal to 35 is in the range of x is greater than or equal to 21 but less than or equal to 50. So, f of x is equal to 180x will be used. Substitute 35 to the variable x and we will get f of 35 is equal to 180 times 35, which gives a product of 6,300. So, you will pay 6,300 pesos. Did you get the same answer? That's nice. Moving on to our second question. Given the functions f of x is equal to x plus 1 and g of x is equal to 2x, find A, f plus g of x, B, f times g of x, and C, f composed with g of negative 2. It's your turn, grade 11. 1 minute starts now. Time's up. Let us check your answer. To get the sum of the two functions, simply add f of x plus g of x. That is quantity x plus 1 plus quantity 2x, which is similar to x plus 1 plus 2x. Combining similar terms, we get f plus g of x is equal to 3x plus 1. To get the product of the two functions, simply multiply f of x and g of x. That is quantity x plus 1 times 2x. Apply distributive property and we will get f times g of x is equal to 2x raised to 2 plus 2x. To get the composition of the two functions, we write f composed with g of x is equal to f of g of x. Next, we evaluate g of negative 2. That is, replacing x by negative 2 in the expression 2x, then performing its operation. Doing so, we have 2 times negative 2. 2 times negative 2 is negative 4. So, we have f of negative 4. Next to this is to evaluate f of negative 4. That is, we substitute negative 4 in place of x in f of x. This gives us negative 4 plus 1. Negative 4 plus 1 is negative 3. So, f composed with g of negative 2 is negative 3. That's it, grade 11. I am happy you made it to our last activity. Now, let us summarize our lesson for this day. What real-life situations can be depicted using functions? Functions may be used to model various situations in business, manufacturing, engineering, and other fields. How do we evaluate a function? We evaluate a function by substituting a number assigned to a given variable, then performing the given operation. How do we obtain new function from the original functions? A new function can be obtained by adding, subtracting, multiplying, and dividing functions. Accordingly, these new functions are called the sum, difference, product, and quotient of the original functions. A new function may also obtain by getting the composition of the given functions. How do we solve problems involving functions? First, represent the situation as a function. Then, evaluate or perform operations on functions as required in the problem. Now, the floor is open to entertain the frequently asked question about functions. Can all functions be evaluated at any real number? The answer is no. We can only evaluate a function at the values of x that are in its domain. We will learn more about domain in our next lesson. Should you have other questions, feel free to approach your mathematics teacher. Before we end today's session, let me just remind everyone to answer the assessment part of your module. Once again, this has been your general mathematics teacher for today. Saying goodbye for now, stay safe and healthy until our next lesson.
Technician at moderator na magiging kaagapin ng mga guro para sa mas epektibong online classes. Magkakaroon din ng virtual communities kung saan pwedeng magsagawa ng follow-up discussions ang mga guro at estudyante gamit ang free online platforms na hindi nangangailangan ng mobile data subscription. Maaari rin ditong gumawa ng group chats ang mga magulang kung saan pwede silang mag-usap at magtulungan upang maging mas epektibo ang pag-aaral ng kanilang mga anak. Assessment. Ang mga estudyante ay kailangang bumuo ng portfolio kung saan ilalagay ang lahat ng ginawa nilang pagsasanay na susuri sa kanilang mga natutunan. Ang portfolio na ito ang pagbabasihan ng kanilang magiging grado. Ang pagbibigay ng marka o grado ay ibabatay sa panuntunan na ilalabas ng DepEd. Ngayong new normal, walang kabataang Valenzuelano ang maiiwan. Kaya tayo na, Valenzuela! Magbalik eskwela na sa tulong ng Valenzuela Live.